A river is flowing from A to B, which are 70 kilometers apart. A boat takes 17 hours for a to and fro journey between A and B. If the overall speed of the boat from A to B is increased by 5% and that from B to A is decreased by 28.56%, then the time taken by the boat for its round trip between A and B will be 22/3 hours. If the boat travels with the original speed, calculate the time taken in hours for the round trip when the water in the river is still, standing still, as in there is no flow of the current in the river. Okay. What do we mean by overall speed of the boat? It's not just the speed of the boat, but the overall speed of the boat. That means the entire resultant speed of the boat along with the river or the current is changed. It's not just the speed of the boat. So if we look at the first part, first statement, we can say that 70 divided by, so speed of boat plus river plus 70 divided by speed of boat minus river, and this is 17 hours. If the overall speed of the boat from A to B is increased by 5%, now 5% increase will become, this is 105 by 100, which is 21 upon 20. So this one will become B plus R, and overall speed is decreased by 28.56. 28.56% is 2 by 7. So 2 by 7 decrease will become 5 by 7 B minus R. And this is given as 22 by 3 hours, which is going to be 20 into 360 plus 2, 62 by 3 hours. Two variables and two equations, so we need to solve this. Well, we can write the first one as, sorry, this should be 20. 21 times of 70 into B plus R, and 7 by 5 times of 70 by B minus R is equal to 62 upon 3. Now, our motive is to solve these two equations. Somehow, if we can write the second equation in terms of 70 by B plus R plus 70 by B minus R into something, this will result in the answer. So we should be able to convert one of the terms into 7 by 5 or 20 by 21 times. So let's say this is 20 by 21 times of 70 by B plus R, and plus 20 by 21 times of 70 by B minus R. We already had 7 by 5 times, and we added 20 by 21 times. So let's subtract that. And this will be 70 upon B minus R. And this is given as 62 by 3. The first two terms will become 20 by 21 times of the first equation, which is 17. And the next one we will have is, this was 20, right? So 21 into 7. So this is going to be 147 minus 100. So this is 47 by 5 into 21 times of 70 by B minus R. And this is given to us as 62 upon 3. Well, what we can do is we can cross multiply throughout by 21 because, or 7, because this is going to be 14. So from here, we will have 20 into 17, which is 340. And the next one, we will have 47 into 14 upon B minus R. And the right-hand side is going to be 62 into 7 because 3 is already present. So we have taken the LCM as 21. So 62 into 7. So this is 420, 434. So if we solve this, we will have B minus R. That is going to give us 434 minus 340, and 47 into 14 should be divided from there. So this is 47 into 14 divided by 434 minus 340, which is going to be 94. So 47 and 94, this is twice, right? So this will turn out to be 7. Now, if B minus R turns out to be 7, and if you put this back in the first equation, that if this is 7, so 70 by 7 is 10 from here, and we need a 7 from here. That means B plus R should be equal to 10. So we will have B plus R as 10 and B minus R as 7. So we will have the value of the speed of the boat as 17/2. Now, once we get this, we can put it in the asked part. So if the boat travels with the original speed as in its own speed, so how much time will it take to come back? So the total distance covered is 140 kilometers, and the speed of the boat is 17/2. So if we solve this, we will have 280 by 17. So this is the time that the boat will take with its original speed. So Charlie, C option makes sense.